Welcome to my channel P Concepts CHM. This is the fourth part of the series of gradient, divergence and curl. Some interesting properties. Del dot del cross A bar is equal to 0. That is a vector that curls. This is the curl. So divergence of curl is 0. A vector that curls does not have a divergence. Here now del cross del phi, that is the curl of gradient, is 0. A gradient of a scalar, it is fixed. It is a fixed direction in space. That means it is not rotating, so it does not curl. So hence that del cross del phi is 0. Same way, if now we can prove that divergence of curl is 0 in this way. We have substituted del, the del operator, and f bar is taken as pi cap plus qj cap plus rk cap. So we multiply the del operator with the or take the dot product with del cross f bar, we get it as 0. We can make it an analogy with the scalar triple product that a bar dot a bar cross b bar is 0. We'll see a problem that if a bar is 2x z square I cap minus yz j cap plus 3x z cube k cap, find the curl of this vector at a point P. The coordinates are given. So we'll find the curl of a bar. We'll write it down in the determinant form as I cap, j cap, k cap in the first row. Second row, deba by deba x, deba by deba y, deba by deba z, that is the components of the del operator. And on the third row are the components of this vector a bar. And we will solve this determinant in this way. Differentiating this, if you see there is no term of y, so the differentiation is 0. Here we can differentiate with respect to z, we get y. Here there is a term of x, so we can differentiate with respect to x, that is 3z cube, and then we have z square. We have to differentiate z square with respect to z, that will be 2z, and that is 4xz. Here there is no term of x, so it is 0. Here there is no term of y, so it is 0. So finally we get yi cap minus of 3z cube minus 4xz into j cap. And then we will have to find the value of this curl at the point 1, 1, 1. That is, put x is equal to 1, y is equal to 1 and z is equal to 1. In this equation we substitute and we get I cap plus j cap. Now if phi is equal to 6x cube y square z, find del dot del phi and del cross del phi. So first in this we require both. In the both the problems we require the gradient of phi, del phi. So we'll find del phi. So substitute del here in the first bracket and here you have phi. Open up the brackets. You will differentiate this phi with respect to, first with respect to x, then with respect to y, with respect to z. So with respect to x we are differentiating here, second term with respect to y we are differentiating, here we are differentiating with respect to z. We get the next step as 18x square y square z I cap plus 12x cube y z j cap plus 6x cube y square k cap. Now we will find del dot del phi, that is divergence of this equation, that is substituted here. You can see del operator and this equation is substituted here. And now we will differentiate the first term with respect to x, second term with respect to y and third term with respect to z. We get here x square, we have to differentiate x square, that is 2x. So 2 into 18 with 36 xy square z. Here differentiation of y, we get 12x cube z, and here there is no term of z, so it is 0. So final equation is 36 xy square z plus 12x cube z. Again now we will find del cross del phi, substituting everything here in the form of a determinant. On the third row we have the components of del phi, that is this vector. We have written down the components, and solving this determinant in this way we get this equation. So you can see that in each bracket everything is the same, the terms are same, so we get a 0. That is, we had seen the property that the curl, this is the curl of a gradient, it is 0. Now show that del dot del cross A bar is 0. Divergence of curl is 0 if A bar is given in this form. So first we will find the curl of A bar in the determinant form, I cap, j cap, k cap, then the components of the del operator, and then the components of the vector A bar, x square y square z, minus y square z, and z square x, and solving this determinant this way. So differentiate first with respect to y. Here there is no term of y, so it is 0. Differentiation is 0. Here there is the term of z. Differentiate with respect to z, we get minus y square, and then we have differentiate here with respect to x, you get z square. There is no term of z here, so the differentiation is 0. And here there is no term of x, so the differentiation is 0. And here with respect to y, we get x square. So finally we get y square I cap minus z square j cap minus x square k cap. Now we'll find the divergence of this vector. So divergence, we have substituted del operator and this curl that we have just found. Open up the brackets, differentiate with respect to the first term, we differentiate with respect to x, second term with respect to y, and third term with respect to z. We can see there is no term of x here, so the differentiation is 0. Here there is no term of y, and also here there is no term of z, so the differentiation is 0. We get divergence of curl as 0. Now prove that del square of 1 by r is equal to 0. Del square of 1 by r. So we write down del square can be written as deba square upon deba x square plus deba square upon deba y square plus deba square upon deba z square into 1 upon r is the, we write down the magnitude of the vector r bar, that is square root of x square plus y square plus z square. So we will first differentiate with respect to x. So for that we will take this term in the numerator, so that can be written as x square plus y square plus z square the whole raised to minus half. And now we will differentiate with respect to x. We get half minus half into x square plus y square plus z square raised to minus half minus 1. Then also we have to differentiate x square also, so that will be into 2x. So 2 will get cancelled out, and we get minus x into x square plus y square plus z square the whole raised to minus 3 by 2. So here we have differentiated this first with respect to x one time. Now we will differentiate it the second time. We will differentiate this with respect to x second time. Here we can use a uv product rule. You can take this minus x as u and this whole term as v. Then differentiate u by keeping v constant. Then differentiate v by keeping u constant. So that is done. We have kept minus x constant here, and we have differentiated the second equation, that is minus 3 by 2 into x square plus y square plus z square the whole raised to minus 3 by 2 minus 1, and also we have to differentiate x square, that is 2x, and then we have to keep this second term constant. Here you can see second term is constant, and differentiate x, so that is 1. It is the same step. So we get this as this 2 will get cancelled out, and we get this 3 and x into x, 3x square into this bracket minus this bracket. We have taken x square plus y square plus z square the whole raised to minus 5 by 2. This term we have taken common. So inside the bracket we have 3x square. Here 3x square remains, and this term, this power is readjusted. We are writing down as we are taking minus raised to minus 5 by 2 outside. So inside we get x square plus y square plus z square. So we get that term in the bracket as 2x square minus y square minus z square. So this is the final equation that we get. With respect to x we have differentiated twice. Same day we differentiate this with respect to y twice, and we get 2y square minus z square minus x square upon x square plus y square plus z square the whole raised to 5 by 2. The denominator remains the same. And with respect to z also we differentiate twice. We get 2z square minus x square minus y square divided by the same denominator we get. So we can find del square of 1 by r. So add up all these terms. The denominator is the same. If you will see, this is 2x square and this is minus x square, and minus x square becomes minus 2x square. So minus 2x square and plus 2x square cancels out. The same thing will happen for the y and the z terms, and you will get 0. So del square 1 by r you get as 0. So any function phi, if you take del square of that function phi, it is 0. So this is a Laplace equation where phi is equal to 1 by r is the solution of this equation. Now next problem, if phi is given as x square y cube z, find del dot del phi. So del phi can be found, that is the gradient of phi. We have to differentiate this phi first with respect to x, then with respect to y, and with respect to z. So with respect to x, here this is with you have to differentiate x square, you get 2x y cube z. Here the differentiation of y cube is 3y square, so 3x square y square z j cap, and you have to differentiate z, that is 1, so you get x square y cube k cap. So that is the gradient. Now we will find the divergence of this gradient, substituting the del operator and this gradient. Open up the brackets, differentiate the first term with respect to x, second term with respect to y, third term with respect to z. So here with respect to x we get 1, differentiation is 1, so 2y cube z. Here with respect to y this will be 2y, so that will be 6x square yz, and here there is no term of z, so it is 0. So that is the final equation, 2y cube z plus 6x square yz. Thank you for watching this video.